right. Hello. People on the back, do you hear me fine? All right. Well, I've been told to stand here in a box model, so we're going through a box model today. All right. So here today we're going to talk about some tips and tricks on improving the performance of your web application or website. When I think of web performance, it's like following a series of basic steps to get to the goal, which is improving the performance of your website. This is how it's going to look like. So from childhood, we know that when you were drawing something, you started from some basic shapes. You draw some two circles and added some lines, added more stuff, you know, dots, curves, fill up spaces, and then at the end, you reach to a point where you have a representable picture of what you were trying to draw. However, as easy as it sounds, performance tuning has its own troubles, and it can go wrong, like this. Now, before you start laughing, this is a picture a 7-year-old girl draw of her mom selling snow shovel on a Home Depot. So you start to see that it can be tricky, right? Performance tuning is not something that you can just go and pick up stuff and apply some fixes to production and voila, you have your improved performance. My name is Yaser. I'm a senior consultant at Redify. I maintain a blog. I do speaking in different conferences and meetups and user groups. And hopefully we will have some fun today. We'll go through a series of steps and easy steps that you can follow along, and at the end of the talk, I'm hoping that you will have some ideas of where to get started. You can find me at Twitter, and that's my email address. That's enough about me. Let's get started. Before we start on going through performance tuning, we should see why we should care. Why we should spend developers' time and companies' money on spending time on something that it might be not useful. So why we should care about improving the performance? Anyone in the audience want to guess what that number is? Any wild guess is welcome. Anyone? What? Close, but not close. This is the number of people on planet Earth using only their mobile devices to do everything. Shopping, browsing, checking email, filling timesheets, anything. That number is huge. One of the reasons why we should care about the performance is people are using their mobile devices and we don't have, like, they're not living in a first world country where they have enough internet. Some people live in Australia, right? They have NBN. So we should really be careful of how we should focus on improving the performance of the website. If we break down this number into different countries, this is how it's going to look like for China. 83% of people are using only their mobile devices. 83%. And they're not just like 25 million people, they're like billions of people. We can come down a bit. In our beloved country, 76% of people are using their mobile devices to do everything. You might not believe it, but it's true. So, first reason why we should care. Second one, we should go to do some research. DoubleClick did a research and they figured that if your website takes less than 5 seconds to load, you will have 57% lower bounce rate. So, if your website is taking from 0 to 5 seconds to load, you will have more users on your website. Very trivial, but it's very important to keep in mind. In another research, which was in a different perspective done by Kissmetrics, they figured that if you have all the shoppers that are going to shopping websites and doing the shopping, if they have trouble getting into website and do stuff, whether it's like browsing different products, whether it's adding it to the shopping cart, purchasing the item, if they have trouble doing that, 79% of them don't come back. They're just gone. They're just going to their competitors using different shopping websites. So that's not bad. That's a really terrible thing to have. 79% is like a lot of people. You might think that, okay, we'll give some good discount and they come back, but I wouldn't, so I know that the users wouldn't as well. Now, the other thing is, they did another research in a different area, and they figured that for every second delay of loading time, you will lose 7% of users. So you will have 7% reduction of conversions of the users. And you might think that that's not a big deal, right? 7%. But if you think of big companies like Amazon, this 7% is like losing $3 million every second. $3 million every second. That's a lot of money. Who want to lose that? So another reason why we should care about performance. Now, it's not just that you lose customers. In the first place, before you actually get to have customers, you will lose your search engine ranking. It turns out that in 2016, Google announced that they're doing mobile-first indexing, which means that while their search engine is crawling your website, if you're not performing well on a mobile device, your ranking is lower than the ones who are performing well. And that was the theory in 2016. It turned out this is a reality in 2018. And in July, they did it. And now if you have a lower performing website, it actually ranks lower in the search engine. It doesn't mean that your website isn't ranked at all. It's just that the ranking is lower. So another reason why we should care about performance. Okay, so we know how important it is. Where should we start? That's the next question you have to ask. The first thing you need to do is choosing some metrics. There are many metrics when it comes to measuring the performance of your web applications. I'll go through 5 most important ones, but you can go through and have a look at the others which are applicable to your website or web applications, and choose a set of metrics and target them for the performance tuning. The first one, first meaningful paint. This is very simple. But from the time user hits enter on a browser URL until they get something, they get some meaningful content, not just anything, not just a bunch of colors or a button with a color. Meaningful content. It can be anything from a header text, it can be anything from menu, app shell, anything. The second one is hero rendering time, which is my favorite. And you can think of hero items on the page as the most important content of that page. Give you an example. Twitter, the first tweet that you see is the most important item of the page. So loading the first tweet very fast is very important. News agency, what do you see first? The headline. What do you see next? The image. So these are the hero items that will appear on the page. So it's very important to keep this in mind. If you want to have more information, go to that link. Time to interactive. This is the time between the user starts browsing your website until they reach to a point where they can interact with the website. Interaction is click on a menu, seeing a menu. Click on a button, get a response. Typing something in the search box and get an autocomplete back or something like that. The next one is input responsiveness. This might look trivial, we take this for granted, but this is very important. It's one of the most important parts in the web application performance tuning, which is if the user is typing something or if they click on something, the response that you have to give them back is like very important. This is the time between they type a character in a search box until they get something back. It might not be that, it might be obvious, for example, if they have to click on a button to get a search result, that's like how much time it's going to take for them to type something. If they're getting an autocomplete list, how much it's going to take to repopulate the list as they go on. So this is very important. And the last one is perceptual speed index, which is the difference between first contentful paint until it gets to a point where they can interact with it. So at this point, it's all text, but a nice visualization helps you to understand what's happening. So let's go to the visualization. From left to right, starting off the browsing until on the far right, the website is fully loaded and it's responsive. So you can sort of see that navigation begins from left. You have the first paint, doesn't indicate anything. It's not one of the critical metrics you need to choose. First, contentful paint, that's one of the most important ones. And then it goes on, first meaningful paint, some of the meaningful content on the page, it might be an article, it might be something. And then it goes on, it's time to interactive. And the difference between the first contentful paint and time to interactive is called page speed index. And the lower, the better, right? Obvious. So, what should we do next? Before we go into performance tuning, we should have some information. We should have some data. Why our users are going away from our website? Where are they suffering from performance? And for information, you will have two very critical sources. The first one is field data, which is your production environment, where the actual users are using your website, where you can sort of find out information about how much time it's going to take for a page to load, how much time they spend on which page, where are they focusing the most, and where are they focusing the least. And you might think that where are they focusing the least is not important, but it is, and I'll show you why. The next set of source of information is lab information. Like you would have a performance test server or a test server or something that you do some, you test it before you deploy to production. And this is where you get some more information about what's happening. And it's very important that you should follow a process when you're dealing with these two sources of information. And the process looks like this. So you go to field data, you go to production, you gather some information, you figure out what's wrong, then you improve something, and then you apply that fix to your test server or whatever it is. You measure the gain, positive, it's good, it has an impact, then you push it to production, monitoring in real-time environment, and then you go back. If it's okay, you roll back the changes. If it's not, you continue on the next phase. And it's very important to do this one at a time. You don't want to have a lot of changes, and when something breaks, you don't know which one broke, had a negative effect on the performance instead of a positive effect. Next step is you have to know your tools. There are two major categories of tools that you can use to figure out about some statistics about how your website is performing. The first one is passive monitoring tools, which are like Lighthouse, which is now integrated in the Chrome DevTools, like Web Page Test, which is a tool that I show you what it does, but it does a really good job of monitoring your performance of the application from 3 different parts of the world, like a real user. And then Yahoo Wireslow, which is one of the oldest tools, but it's still relevant and it's very helpful. You get different information from different tools. So don't use one of them and think that that's fine. Use all of them and then collate that information, see what's the common points and see what's the difference. And then you can focus on where you should spend your time the most. The next one is active monitoring tools. These are the tools that you can integrate into your production environment, like New Relic, like SpeedCurve. And this will have a significant amount of information for you to start from. You remember that we started from from field data? These are the tools that help you to start from there. Now, in terms of Lighthouse, this is what it looks like in the Chrome DevTools. You can sort of go into developer mode and have a look at the audits tab. And when you perform an audit, this is the result you get. They have 5 categories of major categories that they do the auditing, and they will let you what's wrong and what's okay. And you'll see that the performance, for example, for NDC website is like 15%. Now, that's not an accurate number because I was running this in a normal mode. And I'll show you why it's different. But when it comes to commercial websites, if your performance is about 15%, you definitely need to do something about it. Web page test I mentioned, they have servers all around the world. They choose 3 servers by random, and they load your website in real browsers, and they give you information on what's going on. They give you information about all of those metrics that I mentioned, the 5 metrics, and some more information. And then you can collate this information with the information you got from Lighthouse, merge them together, and have a good starting point. So we've done that. We know our tools. What's coming up next? The next thing is we have to have goals. We can't just go and start improving stuff without having a goal, right? We need to know when to stop. That's the most important, because we are burning money. We are spending time on, where we could deliver a feature. We are improving stuff. It has a positive effect on the revenue and on the end user, but it's not something that your manager will appreciate, right? So you have to convince them why it's happened, and you have to have some concrete goals. These goals are the ideal scenario. You don't need to follow all of these, but these are the very good starting point. Apart from input responsiveness I mentioned before, it's 100 milliseconds. So from when the user types something in, the responsiveness should be about 100 milliseconds. You only have 60 frames per second for animations. And when we say 60 frames per second, it's not that you have all those time to run something. You have only 16.6 seconds for your code, and the rest is happening outside of that. So the browser does something, you only have that slot to run your animation. So the less animation you use, the better. That's why when you open up your Chrome and you have a website which has tons of animation, you'll see your CPU fan starting to go on, right? Speed index, that should be less than 1,250, which is like 1 second, 250 millisecond. And time to interactive, so from when you start until it's fully interactive. We mentioned before, on a 3G network, which is now, it gets interesting, it should be less than 5 seconds. So when we say mobile, we are considering that the mobile don't have the powerful CPU that you have on a desktop browser, or even the network bandwidth might be different. So people are still using 2G at some part of the world, so you can't ignore that. When it comes to size, however, it gets shocking, because your bundle size ideally should be 170 kilobyte gzipped, and if you decompress it, it's about 100 megabyte. Now, at this point in the process, you get quite emotional. My emotion was like that. Whoa, how we should do that? How we get from 3 megabytes average bundle size in 2018 to 170 kilobytes? And I'll show you how to do that. It's very hard. It's a really cumbersome task, but the result is very rewarding. And then you go into this mode, because you have to start on it somehow. But it's good. I've done it many times, and it's always full of fun. Don't worry about it. Before you start improving the performance, however, you need to know how the browser works, how they actually render your website, how, when the HTML, CSS, JavaScript, any other asset, how they get to the browser, how they render, because that's when you get the most out of where you should spend your time the most. So when you start sending information to the browser, they form two different document object models. The first one is HTML, obviously, and the second one is CSS document object model, which is only for CSS. And they have this hierarchy of tokens, which I'm not going to go through. It's not relevant to this talk, but if you want to have more information, check this out. It's a really interesting area to discover. Then they merge these two. They apply all the selectors, all the changes that should happen to these two, merge it into something called render tree. And this is all of the tokens. They can be HTML elements in the right spot. So if they have a parent, if they have like hierarchy, this is the full hierarchy. Then it goes to positioning and box tree, which is, for example, which element is in which position. Is they on the right? How much width do they have? Is it on the top of the page, on the bottom? If they position absolute, and all that sort of stuff. And then the last one is paint. So that's when the user actually sees something helpful. Now, all of this, if you remember from the metrics, all of this is happened. We are still in the first contentful pane. All of this, first contentful pane. So we only had 1 second to reach to that part. So you sort of see that why it's important to send information very, very efficient, because we only have to fill this gap very efficient. Now, after this, we need to know the critical rendering path, which is not really about performance of the website. It's mostly about perceived performance. So how the user is interacting, how the user is perceiving your website to be performant. You can have a really good performing website, but then user have to wait for, I don't know, 10 seconds to fully see something, and then it's very fast, but that doesn't mean that the user is happy because users already left. They're like 5 seconds and they're gone. So that's why it comes to a optimized version of rendering, which is progressive rendering. It's like you send information in chunks, in smaller chunks, and then the browser is rendering those while you're sending more stuff. And that's what happened with HTML5 because they added the streaming ability to HTML. So you can sort of stream your HTML to client instead of sending the whole file as one request and response. So that's where it gets interesting because Google does it. When you go and you open up your Google search page and you start to type something, they've already sent the response of the header of the search page result back. So you haven't typed anything, you're just browsing the page, but they've already sent the response of the header back. So when you actually type something and click save, that's when they go and figure out what's wrong, and then they search, and then they send the result back. But you see the result really fast. But that's perceived performance. It's not that they're doing the whole thing in one place. They're streaming stuff into the browser. So rules to keep in mind in this area is that you have to stream the HTML to client if you want to have optimized progressive load. And then get the CSS to the client fast because that's what the browser needs to fully render the page. CSS is a very important part. Did we miss something? Our friend JavaScript. Yeah. Yay. We all love JavaScript, right? We write tons of JavaScript for no reason. We even changed style with JavaScript, which is ironic. Images. This is very important, and I'll show you why. Web fonts. We all love Google fonts, right? We use it intensively in everywhere now. And external resources. You might take this for granted, but Google Analytics, ads, all of these add to your loading time because browser has to wait for it. If it's a script and you don't treat it right, browser waits for all of those and then renders the page. So you have to be careful of all of these external resources as well. Now, in terms of JavaScript, there are three categories of JavaScript, right? There are external JavaScript, which is like a script tag with the source, and the request goes to network, comes back the result. And then the internal, which is like a script tag with all the JavaScript inside the script tag, and it gets bundled by HTML. So you have all of the JavaScript plus everything else. And then inline, which don't even talk about it. Don't even go there. So JavaScript can change DOM. That's one of the main reasons why JavaScript is a render blocking element. They can add stuff, they can remove stuff. JavaScript can change attributes on elements. So that's why browser needs to wait for JavaScript execution before it renders the page. As mentioned before, JavaScript can change styles. So that's affecting CSSDOM. So JavaScript should wait for everything to finish, and then the page will be rendered. Because of these two reasons, JavaScript is a very tricky area, so we need to treat it the right way. So let's get optimizing. I want to introduce you to PRPL pattern, which was introduced by Google in 2016. PRPL pattern stands for push, which is, I mentioned before, you push the stuff before even the browser has a request for it. So let's say you have, I don't know, your website is like 3 areas. You have shopping part, you have support part, and then you have the main part. And then in the shopping part, you have a different style sheet file, and then you push that on the main request before even it gets requested. So it's cached in the browser. By the time user navigates to the shopping part, they already have the resource ready to hand. It's render, and we've seen all of the major SPA frameworks like Angular, React, Vue.js, Polymer, all are doing some sort of server-side rendering to improve the SEO, to improve the performance, to improve the initial load time. And that's very important. That's why they're spending time on server-side rendering. So you render something on the server, You just send that information to client, it gets rendered. Browser doesn't need to figure out what should happen. It's already done everything. So it's like a virtual DOM which is rendered on the server. The HTML is like just sent to the client as a static file, and it just gets rendered very fast. Pre-cache, I mentioned before, you can pre-cache the resources. This time, it's not like pushing. You're pulling information before they need it. And you can do this by using pre-cache and preload strategies that I showed you earlier. I'll show you later. And then lazy load them. So instead of sending everything together, if you have a shopping part and you have a, the support part, and these are not required on load, just put them in a different chunk and then request them while they're needed. You don't need to send everything up front. That's why you have 3 megabytes of size taken by the main bundle. So that's why you reduce the size of the bundle. And if you need more information, head to the developers Google and find out about this pattern. It's a really effective pattern and it's helped a lot. In terms of style, so I mentioned preload and pre-cache. This is how you do it. You put your link tag, instead of having style sheet, you put preload. That's how you tell the browser to preload that particular resource before it's even required. So let's say you have your main site and you have some script tags in the head. You preload the script tag of the shopping beforehand. And then it gets requested in the background. It doesn't have any effect on the DOM. It just gets requested back, responses back to the client, and then by the time it's ready, it then can be used. And it's not bad to have inline CSS, unlike JavaScript. If you think of critical rendering path, you can sort of see that you can put your main and necessary CSS, which should be very small, hopefully, within the HTML in a style tag. That's how the webpack is doing it, because it figures out what's the main important part of the CSS and it sends it out with the HTML. That way, there is no additional request to get a CSS, so the CSS is like rendered really fast. And this is an example of how you can do preloading of a CSS file. So you do link instead of style sheet, it's now preload. You mention the href like usual, and you have as keyword, which is like an attribute that you tell the browser what's the nature of this particular resource. It might be a font, it might be CSS, it might be JavaScript. And then there's a bit of extra work to be done as of now, because the browsers don't support automatically changing the rel attribute back to the style sheet once the request is loaded. So you have to have that much additional thing. I just put it as inline. Don't use this inline JavaScript. You should have a separate script which looks up what the resource is and then changes the rel to a slide sheet, which then the browser applies the CSS. And if you're using this, bear in mind that this is not supported fully still in all the browsers, so you have to have a no script tag, which is like a backward compatibility option for a normal link rel style sheet. So if the browser doesn't support pre-caching, then this is used. So you just do no script, and then you add your style sheet in there. All good? I'm not too fast, I'm not too slow. There are a lot of stuff I need to cover, and I'm just going in a flow. Hopefully you can catch up. If you're using Webpack, this is already handled by this plugin. So it's a preload Webpack plugin. This is how you use it. You just add it to your plugin array and then configure it like that. And you can sort of have a either a pattern matching to the files that you mentioned, that this resource should be preloaded with this as keyword, and then it does all of those stuff that I showed you earlier by default. So that's handled for you automatically. Enough CSS, let's go JavaScript. That's more important. There are a couple of small techniques and subtle techniques that majority of developers that I've talked to didn't know about. First of all, defer. When you have your JavaScript tag and you put a defer attribute on it, browser knows that they shouldn't care about this content of this JavaScript file. So the request goes to the server, the response is coming back, but the browser is rendering it's not blocked, so it's rendering your HTML and CSS and everything else. And then once the rendering is fully done, then the file is applied to on top of that. So it's like you might have seen it sometime. It's like a flashy moment of a unstyled HTML in a page, and then it gets fully styled. That's why they have defer. So they don't want to stop the rendering by JavaScript, so they use defer. But this is sort of an aggressive version. There is a better version, which is async. And async tells the browser to wait for this file, so it keeps continuing with the DOM, but as soon as the resource comes back from network, it stops the DOM rendering, it applies the JavaScript, and then it continues on. So it's like a progressive way of doing this. That's why you broke your JavaScript. You can break your JavaScript into smaller chunks, and then you have different installs within the body. It's not going to be at the end anymore. You can put it anywhere if it's like relevant to that part only. And then you can do it like this. So you can put it asynchronously, load the JavaScript and apply it, and the browser is happy, and the user is happy, and everyone is happy. And if you're not using one of those, just put everything at the end of the body. Don't put it in the head, don't put it in the top of the body, because JavaScript is a render blocking item. So keep that in mind. Apart from this, JavaScript has a cost. You need to know whether you can afford it. All the major performance bottlenecks have been proved to be caused by JavaScript. So bear in mind, less JavaScript, the happier you will have your users. Some other techniques regarding JavaScript is code splitting, which I mentioned before. So you split your application into different modules, and then you load the module as it's required. You don't load everything in one go. You can use Common Chunk plugin for the same reason. It actually has, let's say you have some shared JavaScript, it bundles that in a single chunk, it sends it to the client, caches it, and then you can sort of reuse that everywhere else in the application. Or you can use the preload or pre-cache strategy with JavaScript as well. It's not just that you have to have defer and async. You can have preloaded JavaScript for a page that is required, and it's not even met yet. You will have dynamic import and require. This is something that added to the browsers lately, and it's very helpful because you can dynamically import a JavaScript into your app based on a condition. So if that JavaScript is not required at all, you don't load it. If it's required based on an if condition, then you will load that on the fly, and then there will be a separate request, and so on. Use a bundle analyzer. If you're using Webpack, there is the Webpack Bundle Analyzer package that visually shows you how your bundle is constructed and which element is taking what space. So it will show you a sort of a square with all those sort of different components that you're using, including the framework stuff, and will show you how much size each of those are allocated. So you can sort of go and focus on the areas where you don't need. As an example, an ordinary example, if you're using Angular, and if you're using Angular, I don't know, material design, the material design is a very chunky module to use. So instead of using everything from material design, only use those that you require. If you use everything, the Webpack Bundle Analyzer lets you know that you haven't used this and these are taking this much time. Web fonts. When it comes to web fonts, it's very important to know that they can be cached. These are static resources. And you can use a CDN which has caching. You can use a local caching in the browser for those. And then you can use the same techniques as preloading and pre-caching for web fonts as well. The other thing to bear in mind is that do you even need web fonts? There are fonts that are system fonts, and they are very close to what you need. So talk to your UX if they are offering a web font and see if you even need to have a web font. Because web fonts are very chunky, so they actually take some time to get loaded. If you really should have a web font, think about loading strategy. Have a look at eBay's font loading strategy, which is a really interesting article. They spent 2 years on figuring out how should they load web fonts. That's an intensive, like a course on just loading web fonts. You see how important it is that they spend 2 years on this. And if you really should have it, use face font, which is an attribute that you can put in your CSS, and have a backward compatible font that if the web font is not loaded yet, the browser isn't blocking your rendering. So your content is shown to the user with a different font, as soon as the font is available, then that gets applied and they'll see it in the main font. Images. This is a really interesting part because it's been proven that more than 50% of page weight are images. So what should we do? The first action is use the right dimension. You don't need to send a really large image if most of the users are mobile users. So think of what dimensions are you targeting and then rectify those images for that particular dimension. And I'll show you how. Use next-gen formats. Next-gen formats are WebP, JPEG 2000, and a bunch of more. Use those formats as possible. They have the best compression methods and the best rendering methods. So if you use one of the newest next-gen formats, because it's not fully there yet in all the major browsers, you should have a fallback strategy as well. And I'll show you how. Compression. Compress your images. You don't need to go and compress your images when you're adding it to the resource. You can have it as part of the build process. Libraries like ImageOptim, they actually are nicely put into the build project, and then all the images are compressed when you're building your application, so you don't need to do additional stuff. So they take care of that for you. So think of using these techniques. And lazy load images, like pre-caching and preloading. This can be used for images. If the image is not the most important part of the page, lazy load it. Let's everything to finish first and then load the image later. And use less of them. If you don't have the usage for an image, if you just care about visualization, talk to your UX and figure out a way to better represent the information on the page without an image. That's very important. And majority of UX designers already are doing this. At this point, let's have a break. I've talked to Rob Moore, who is one of the co-organization of DDD Perth, and I took his permission to go and fiddle with DDD Perth website. This is how it looked like before. 33% on performance, not that bad for a server-side rendered application, but I knew that there are some stuff that need to happen. And the first thing that I realized is that they are suffering from the same thing. They are using the wrong dimensions, they are using the wrong images in terms of a mobile version. So the first thing I did, I pulled down the source code and I changed all of the images to progressive images. Progressive images are like loading like this. They appear fuzzy in the page. It's like streaming an image to the client. So it's very helpful if you have a lot of images to make them progressive so they don't, the perceived performance at least is improved a bit. And then I used source set to mention the dimensions that I'm targeting and then what image I want to use. So I have WebP images for those top ones, and then I have a fallback, which is JPEG, because people might, the browser might not support it. And then I have the last one, which is used if none of those media query are met. So if there is nothing that is matching all of those criteria, then the last one is used, which is the default image. By just applying these two techniques, this is how it looks like afterwards. Just taking care of images, 33% bump in performance. You can sort of see why it's very important to take care of that. I didn't push these changes back. I'll do it after the conference. So to recap, I did a analyzation on the DDD Perth production environment, which was their website. I applied some improvements. I deployed it to my own Azure instance because I didn't have access to that. And then I measured the performance again, and you can sort of see this is the circle that you should go to. One step at a time, you apply a change, you measure the performance. If it's good, move on. If it's bad, roll back. Very simple. When it comes to caching, people really underestimate the power of caching. There are many different types of caching. You can cache stuff on the server. If you have some sort of dynamic data that needs to be sent to client, whatever it is, if you're getting it from a blob storage, from a, I don't know, database, you can cache those stuff on the server if they're regularly used. So when the request comes in, they send back to the client really fast. But then you can use client-side caching. And this is very important because that doesn't happen by default. You need to set exact headers plus the duration on the resources to make sure that these resources that are sent back to the client are cached for the right duration. Let's say if you have a web font or if you have a style sheet which doesn't change that regularly, you can sort of set a 1 month expiration on that, and then the user will never request that again. The browser is just taking care of that for you. But you need to know the right headers and set it. Use a CDN. When it comes to CDNs, they're very helpful. Even with images, there are CDNs that you need to pay for, obviously, but they do the resize for you based on the dimensions of the page. So if you use a CDN for anything regarding whether it's a web font, whether it's static resources, this is very important because the local users have a very better experience. Imagine you're loading a website, I don't know, from Buenos Aires that is hosted in China. How much that's going to take? And imagine you have a local server in Buenos Aires and then you're using that for resources. So it's very, very performant. There are other techniques that have been covered in this conference, like you can use service workers to cache resources, which I think Phil Nash covered that before, and we have a workshop tomorrow. Make sure to go there. I'm not advertising. But caching has many different areas. It's very diverse. I'm not going too deep into caching, but this is one of the most important ones. How are we going now? Are you guys bored yet? If not, we'll go to a demo. Yay! All right. So, I have this little application which is written in React. And if the Australian internet allows, it loads some cat food. I try to avoid from cat pictures, so I'm into cat food. All right, so nothing fancy, bunch of cat food, it appears on the page. Let's do a performance review. So we go to DevTools, and then we go to Audit tab, and then in the Audit tab, we set this to mobile. That's what we are targeting. We leave this for performance. We uncheck the others because it's going to take so much time. We use the simulated version. We'll see a difference between the simulated version and applied version later. And then we do clear storage just to clear any cached items from this website. And we do a audit. It goes and simulates that with a 3G, fast 3G, and a 4x throttle CPU. Obviously, it's not going to be accurate because of the speed of internet, but all right. How are we going? Oh, 0. Perfect. All right. So let me introduce you to Chrome DevTools. In this panel on the Audit tab, you'll see some metrics. We talked about metrics. You can go and choose the right metrics, but you can see that we have like 20 seconds delay in first contentful page, and then the rest. In the bar below, you see how the website looked like throughout the time. Let me just do that just to make sure we see more stuff. All right, so this is how the website is looking like throughout the time from rendering. In the next section, you have opportunities, which is very important. This is exactly pointing you to the right direction. It tells you where to start. So we'll see how we leverage that. The next one is diagnostic page, diagnostic section, which lets you know what's going on in terms of processing and rendering the app, running JavaScript, and where you can focus. And then in the last section, it tells you what are you doing good. So you can sort of see that these are the things that we are doing good. So, all right. Let's go and dig into this. So the first thing that comes in here is like the text compression is something that we need to do, and it has a really big important thing. So before we go, we investigate. We go to Network tab. We'll make sure that the use a small request routes is ticked, and then we reload the page. And you can sort of see two numbers appear here, right? If I can get hold of that and that. So if I go, all of these numbers are equal, which means that the text compression is not applied. So let's fix this. We come here and we enable text compression, which I've done before, and we apply it. We wait for the build to finish. We go back to here, go back to audit again. We are still 0. We'll do another audit, one step at a time. We'll wait for the audit. You can have popcorn or watch a movie at this time. All right, seems like it was successful. So we are bumped up to, it's not a big number, but it's still something towards having a better performance. And you can sort of see that the page is now rendered just a bit earlier in the process. Now we come down. Seems like the next thing we have to target is images. I happen to know that this is really easy to fix, so let's fix that. We come here. We come into the models, and we change this to small. I've created this so I know, but you have to investigate to see what images are really needed. So let's go and do another edit. By the way, this code is available and it's on the Google's Google Developer website. I haven't written this. I just came up with an idea of throwing some twist in the talk, so I just grabbed this last night. And all right, 4, getting there. What's the next one? Well, it seems like we have some render blocking elements. And if we open up this section, it will show you that seems like we're using Lodash in jQuery. And we have to investigate whether this is true or false. So we just do Control-Shift-P on Windows. I have no idea what's the Mac version, so someone help me out. We go to block, and we choose Show Request Blocking. Appears here. Now we're still in Chrome DevTools, remember? We're using this powerful tool. If I can get the hold of this. We add a pattern. And I know that this is inside libs star, so I'll just exclude that. I'll go to network, and I do a reload. And you can sort of see that the this is hard, not the mouse, but hopefully. So we're blocking those requests. See that they're red. And let's do another audit to make sure that, let's first, because we have blocked this, let's first see if the application still works. We click on it, works, we click back, comes back. So apparently it has no effect. So we're blocking some JavaScript, it has no effect. So let's, for trial, let's remove those. So we come here and we get rid of these two. We don't need them. We wait for the build to finish. Seems like somebody just logged Lodash. come back here into audit tab and do another audit. Wrong. Let's see how we go. Oh, 7. Nice. Getting there. I told you it's a very slow process, but it works. All right, let's see what we can do next. So it seems like we are good in this area, so we don't really care about opportunities anymore. We sort of have a look at the main thread, and it seems like it's taking a lot of time. So this is like the JavaScript running and other stuff happening, and then you can sort of see that how much time spent on what stuff. But from here, you sort of have a hard time understanding what's happening. Let's come up with another view. So again, Control-Shift-P, and I type coverage. And I come here. So this is code coverage view. I do a reload here. Let's actually reload the whole app. All right, so let me just come here. This is my main bundle file. The good thing about this is that it shows you a green bar where these lines are not used, are used, and a red bar where they're not used. So it lets you know that which part of your JavaScript got executed and which part didn't. It's very helpful to identify the parts that you don't need to send to the client at first. So that's a good thing. So we know that we have a lot of comments and stuff. So if we go to production mode and minify those files, should get some benefit. But let's see what else we can do. We come to the performance tab. We click on the performance gear and we do fast 3G and 4x slowdown. This is actually applying those changes. So you know the simulated version, this is the actual version. And let's do a reload. So it's profiling how the application is doing. All right, so from the top bar, you sort of see that here we have a lot of CPU usage at first. We don't know why, but we sort of see that there is a lot of JavaScript execution here. And when we come to the bottom here, we have a couple of different sections. The user timing section is that it shows you like how much stuff are taking, and it's from the top to bottom. It shows you like the framework code that is run, and I know that, for example, if you change to production mode, that top bar that React is taking is going to improve a bit. And then this is my app. But this is the timing section. If you want to really know what's happening, you have to go to the main section. In here, stuff from left to right happens. So left happens first, right happens afterwards. And then from top to bottom, this is like the call stack. So which method called which other method. So for example, from here, this method is called by this, and then this method is called by that, and then so on and so forth. And you can sort of see, you can zoom in here to have more view, and then you can hold your mouse and come down. And I happen to know that here in our app, we have a function here which is taking so much time, and it's called mine Bitcoin. I don't know who put that in, but let's fix it. So we come here, we go to our app, and okay, somewhere is mining Bitcoin. Let's comment that out. But you sort of see where to actually focus, where to go and find the methods which take so much time, and then how to target them, how to find them, and how to fix them. So it's a very powerful tool. Definitely use this. Let's come back. Let's clear these so we don't mess up with the next audit. Where is that? Let's go back to online, no throttling, come to audit. We are 7. We do another audit. Let's see how we go. Oh man, this is good. All right, there's a catch here. Remember I told you that when you're doing profiling on Chrome DevTools, don't use the normal view. That's why, because I have a lot of extensions installed in the Chrome. All of those extensions are injecting stuff into your page without you knowing. So the way you can sort of, where is my mouse? That just shows you. All right, let's do this, but this time using a incognito window. Do that. We bring up the DevTools. We go to audit. We do an audit, same conditions. This is the incognito mode, whereas that was the normal mode, where I had all the extensions enabled. So you see that it really impacts, especially if you, so even here I have some extensions enabled in incognito because I do some testing sometimes. But you can sort of see that how you can use a powerful tool in your favor to sort of figure out what's wrong and where to start and to target. All right, enough of demo. Let's go back here. All right, so we did the caching, CDN, demo. These are the resources that I've used to prepare this talk for you. Hopefully you've enjoyed this. My slides on the last link. You can sort of grab those slides and have a look at all of the different techniques. And if you want to go further, all the links are in the slides. And with that, thank you so much for coming. It was a pleasure presenting to you. Good luck.